Hi guys, so hopefully by now you've done the self-check quiz for the section 6.5. It's a short class today, so I'm going to try to keep this brief, but real quick here we have this really awesome poem about a rhombus. A rhombus knocked upon my door and said matter-of-factly, the number of my sides is 4, of matching length exactly. 4 angles have I, 2 acute and 2 obtuse opposing. How geometrically astute and thoughtful for disclosing. In fact, it said, it's true I am a type of parallelogram. I said, I will bear that in mind when equilaterally inclined. So it says here, find the error, not necessarily an error, but maybe something that might not be true. So take a second, see if you can figure out what that might be. Which of these things might not be true for a rhombus? So I would say here that the third line, where it says 4 angles have I, 2 acute and 2 obtuse opposing, that's usually true, but there's one case where it's not true, if you could think about that. When would a rhombus not have 2 acute and 2 obtuse angles opposite from each other? Yeah, so it would be when it is a square, right? So if a rhombus is a square, it has right angles opposing all the way around. So that wouldn't necessarily be true, but it works pretty well in this poem, so I guess we'll let this guy slide here. So today is 6.6, trapezoids and kites. This is our final section of quadrilaterals. We're going to look at just some properties of both of these things and basically how to use it. A couple examples. All right, so starting with trapezoids here. You've seen these before, but to define them and a couple properties. Trapezoid is a quadrilateral with exactly blank pair of parallel sides. So that would be 1. Exactly 1 pair of parallel sides. So you can see in the example here we have these two sides. ST and RU are parallel. So that is a trapezoid. Another cool thing here, a mid-segment, also known as a median of a trapezoid, is a segment that connects the midpoints of the legs of the trapezoid. So you might want to draw this diagram in your notes up here, but STUR, it's a trapezoid. If I connect the midpoints of the legs, okay, so here's a leg, TU, here's a leg, SR. If I find the midpoint of those and connect them with the segment, that would be what we call the mid-segment, or the median is another word for that. Okay, so I have a trapezoid here. I found the midpoints of each leg, there they go. So the dotted line here would be my mid-segment. So dotted line is the mid-segment. Now you can find the length of this. You can find the length of the mid-segment by finding the average of the bases. Of course, the average, you would add the bases and divide by 2. All right, so that's how you can find the length of the mid-segment for a trapezoid. Okay, so again, in this trapezoid, these would be the parallel, those would be the bases, and the other 2 would be the legs. All right, now up at the top, the one up in this diagram here is an isosceles trapezoid. So just like an isosceles triangle, an isosceles trapezoid, the legs are congruent. Okay, and you can see that. They have tick marks up there. SR is congruent to TU. So this is an isosceles trapezoid up top. So the legs are congruent. 2 other properties. Both pairs of base angles are congruent. So up in the diagram here, I'm just going to mark those. So base angle here, angle R is congruent to angle U, and angle S is congruent to angle T. Of course, they're not all congruent to each other, but R and U are congruent, S and T are congruent. And one more item there, the diagonals. If you draw in either of the diagonals, they would be congruent if it's an isosceles trapezoid. Okay? So feel free to pause at any time if you need to for your notes. Okay, so moving on here. Just a couple examples. If you want to pause and give these a try, you can do that. If so, you can pause it now, and I will go through these just to make sure we're clear on what we got. Okay, so number one, measure of angle D, and there's a couple ways you could get this, but the way I'm going to look at this is, okay, I have parallel sides, parallel lines, A, B, and C, D are parallel. So that means angle A and C would be same side interior, or consecutive interior angles. So what do we know about those? They have to add up to 180 degrees. All right, so angle C would have to be what? 55 degrees. And that would make A and C add up to 180. And this is an isosceles trapezoid. Notice the tick marks. So C and D, what's true about those two angles? They are congruent. So angle D should be 55 degrees. Okay, that's one way to do that. You could also use the fact that all four angles in any quadrilateral add up to 360 and get it that way. A and B are also congruent angles, so this is 125 up here. You could get it that way as well. Okay. Number two, measure of angle L. Measure of angle L, again, you could look at this the same way. This is isosceles. Both legs are 5. Here's our parallel bases. So K and L, think about those. Those would have to add up to 180, so L would be 140. Or again, if you use all the angles, J is congruent to K, so this is 40. Angle M would also be the same as L. And if we add the four of those angles together, we should get 360. Okay, so angle L, 140 degrees. All right, now down here to the mid-segment. So M and N are the midpoints of the legs. So MN is the mid-segment. HJ is 32, LK is 60. What we just said about that, the rule would be to add those, average them. So that's what? 32 plus 60, that's 92. Divide by 2. MN, the length of MN would be 46. They didn't give us any units there. We don't know if it's inches, feet, whatever, but it would have to be 46, the average of the two bases. Okay, and then number 6, they kind of change the numbers. HJ is 18, that's a base. MN is 28, that's the mid-segment. We got to find the other base. We got to find LK. So let's just use a variable here. Let's use X to represent the length of LK. So we would have to do 18 plus LK, which is X, divided by 2, and we're going to get what? 28, because that's the length of the mid-segment. So we know the average is going to have to be 28. We know one of them is 18, so we got to find the other side. All right, so we could solve that, multiply by 2, so 18 plus X equals 56. Subtract 18. And what is that, 38? 38 would be LK. Now that would make sense, right? Because what's halfway in between 18 and 38? Well, there's 20 apart, so halfway in between those would be 28. And that makes sense. So LK would be 38 in this case. All right. So with coordinates, we can figure out here if it's isosceles. Well, first of all, is it a trapezoid? We know it's a quadrilateral, has 4 sides. Is it a trapezoid? And if so, is it isosceles or not? We got to figure that out. Okay, so a couple things we could do here. If it's a trapezoid, what has to be true? What's the main thing about a trapezoid? It has to have one pair of parallel sides. Well, how are we going to determine if something's parallel from coordinates? Yeah, we got to use slope. We got to use slope here. So if we use slope, we can figure out if they're parallel. If they have the same slope, they are parallel. So AB, we could do the slope of that. So remember, it's y2 minus y1 over x2 minus x1. So that would be what? 2 minus 1 over 3 plus 1 be 1/4. All right, how about BC? BC would be negative 2 minus 2, that's negative 4. And then 1 minus 3 is negative 2, and that equals positive 2. CD, find the slope of that one. So it'd be negative 1 plus 2, so it'd be 1. And then negative 2 minus 1 is negative 3. So that's negative 1/3. And then AD or DA will be our final side here. And the slope of AD would be negative 1 minus 1 is negative 2. And then negative 2 plus 1 would be negative 1, which comes out to a slope of 2. Now you notice BC and AD, same slope. So those are parallel. BC and AD are parallel. So this is a trapezoid. Okay, so we answered the first part. Now the other part is it isosceles or not? Well, what makes it isosceles? What has to be true in isosceles trapezoid? The legs are congruent. Well, which ones are the legs? That's the question. Okay, so we kind of need to know that. If you look at it, though, the ones that are parallel, those are the bases. Those are the bases. So we need to look at AB. That's a leg. And I'm sorry, not AD. CD would be the other leg. So we have to determine, are AB and CD congruent? What do we have to use for that? Well, we got to use distance. So AB, you got to do the distance formula for that. So if you want to go ahead and pause now, do distance for AB and distance for CD. If they come out the same, then we know it's isosceles. If not, it's just a regular trapezoid. Okay, so here's what I got for distance. I got AB was square root of 17, and I got CD square root of 10. Obviously not the same. And if those are not congruent, this is not an isosceles trapezoid. So it's trapezoid, but it's not isosceles. Okay, so that's how you'd figure that out. You gotta use slope to see if it's trapezoid, and then take the two legs, do your distance, and see if they're the same to determine if it's isosceles or not. All right. So then the last part here would be kites. Now a kite is another term that gets called a diamond a lot, which there's no such geometric term as a diamond. A kite is what we normally think of when we think of a kite that you fly. It's that type of shape. So it's quadrilateral with exactly two pairs of consecutive congruent sides. So consecutive congruent sides. So you can see the diagram here. We have MNPR. We have single tick marks here, and then we have double tick marks over here. That's what makes a kite. A couple key properties here. The diagonals are as they look. They are perpendicular. Perpendicular. So we can mark a right angle there in the center where the diagonals cross. Also, exactly one pair of opposite angles is congruent. Now, which one is it? Well, it's kind of obvious from in the diagram. Down here, angle R, that's a smaller angle than up at angle N. So it's not those. It would be this one and this one. So angle RMN is congruent to angle RPN. One pair of opposite angles congruent. That's always true. Okay, so quick example using that. We have a kite. We have an 80 and a 60 marked there. Obviously, those are not congruent. But if those aren't congruent, then think about this. Angle X and Z would have to be congruent, right? Because it's a kite. And so 80 and 60, okay, well think about this. It's quadrilateral. How many degrees total are inside a quadrilateral? 360. So we have 80 plus 60. So we already have, what, 140 degrees? So if we take that away from 360, so 360, take away 140, because we already have 140 degrees marked there between the 80 and the 60. So we have 220 degrees left. Well, we have to split that then between angle X and angle Z. So 220 divided by 2 equals 110. So angle X and Z, each of them, should be 110 degrees. So the answer to the question would be angle Z is 110 degrees. Okay? Pretty simple. Okay, another quick example here. We got a kite, and we need to figure out BC, the length of BC. Okay, now we have the diagonals marked, so we have 5 and 5, we have a 4 and a 12, but that's it. We don't have anything else. So we got to use what we know about a kite. Well, a kite, what's true about the diagonals? They are perpendicular. Now if we're trying to find BC, well, look what we have here. We have a right triangle. So what can we use to find the third side? You got it, Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. 5 squared plus 12 squared equals c squared. Do our square roots, and we should get 13. So BC is going to be 13. Okay, so we had to know that the diagonals are perpendicular. And then once we did, we figured out the Pythagorean theorem. Okay, and again, it's a property of a kite. The diagonals were always perpendicular. All right, so if you want to pause right now, just kind of answer these questions to yourself. Look back to your notes if you need to kind of organize your thoughts here and be able to use this stuff. So we pause that video now and answer the questions. All right, so only assignment today since it is a short day. If you go back to Canvas and click the 6-6 homework, that'll pop up. It's our usual homework practice paper. It's just in a PDF form. So you can look at that and you can solve those, answer those on paper or in your notebook, because we will be submitting these on Friday. We have our test Friday, Chapter 6. That means tomorrow is review day. We'll be doing some review stuff through Canvas. And just a reminder, Alex is due this Sunday, so keep that in mind. All right, we'll see you later.